For the last 50 years, the entire tech world has played by one simple rule: smaller is better. But as we step into the quantum era, that rule is about to be completely rewritten. You see, the race is no longer about size. It's about something much, much harder: purity. Today, we're going to talk about the one technology that might just solve the single biggest bottleneck holding back quantum computing.
This right here, this is the fundamental shift we're talking about. The old frontier, classical computing, was all about miniaturization. How many transistors can you cram onto a chip? But the new frontier, quantum computing, it's about making things incredibly atomically clean. We've moved from a game of engineering to a game of purification, creating a perfectly silent environment for these fragile quantum states to actually do their work.
But here's the thing: this new challenge is a beast. All of our incredible success in making things smaller doesn't really help us here. In fact, you could argue it's created a whole new set of problems that are now throttling the entire quantum industry.
Think about it. Our entire multi-trillion-dollar semiconductor industry is designed to fight enemies we can see, like dust particles. We build incredible clean rooms for it. But what do you do when the enemy is invisible? When you're not fighting dust anymore, but the chaotic behavior of the atoms themselves?
And that's why the concept of a traditional clean room is almost obsolete for this problem. The issue isn't some speck of dust that lands on the surface. It's baked right into the material itself. A single atom out of place, a tiny defect in the structure, can cause a total catastrophic failure of the device. So, atomic chaos. It sounds dramatic, I know, but what does it actually mean, and why is it so devastating for quantum performance? Well, understanding this is really the key to unlocking the whole thing. In technical terms, it's all about something called decoherence. Now, the best way to imagine a qubit, a quantum bit, is like a perfectly balanced spinning top. As long as it's spinning, it's computing. But any tiny vibration from its environment, what scientists call noise, can just knock it right over. That collapse, that's decoherence. And it is, without a doubt, the #1 reason quantum devices are so hard to build. Now, here's the kicker. A huge source of this deadly noise comes from silicon. That's right. The very material that powered our entire digital revolution is a massive roadblock in the quantum world. Why? Because its surface is naturally disordered, it's contaminated, and it creates this constant fluctuating charge noise that just destroys qubits. Now, the industry has been trying to patch this problem for years, with all sorts of clever workarounds. But as one expert so perfectly put it, these are just bandages on a structural wound. You're not actually fixing the underlying problem. And to really move forward, we have to heal the wound itself. And this is where a real breakthrough technology comes in. It's a completely new way of thinking that shifts the strategy from just managing the damage to eliminating the flaws at their source. It's called atomic level purification, or ALP. And let's be really clear, this isn't just another surface treatment. This isn't about polishing something until it's smooth. This is about completely rebuilding and re-engineering the material, atom by atom. So how does it work? Well, ALP has 4 key functions. First, it creates a surface that is truly atomically clean, a perfect blank canvas. Second, it goes in and repairs the defects deep within the material's structure. Third, and this is the big one, it builds a foundation of absolute crystalline perfection. And finally, it's a process designed from the ground up to be manufacturable at scale. I really want to drill down on that third point, crystalline integrity, because that is the core technical differentiator. This is what makes ALP a total game changer. Okay, look at this. This is the difference. Standard fabrication methods, what everyone uses today, creates an amorphous layer of silicon dioxide. It's a jumbled, chaotic mess of atoms. It's like trying to build a skyscraper on a foundation of loose gravel. But ALP technology engineers a crystalline layer, perfectly ordered. Every single atom is exactly where it needs to be. You're no longer building on gravel, you're building on solid bedrock. And the strategic implication of that is just enormous. It means you're taking luck out of the equation. Quantum fabrication stops being a game of chance, where you hope for a good outcome, and it becomes a science of precision, predictable, repeatable, and reliable. And that reliability, that predictability, that is the key to finally unlocking scalable quantum computing. It's the missing bridge that gets us from one-off experiments in the lab to mass production in the fab. And please, don't think this is some far-off futuristic problem.
We're talking about 2026. By then, scalability will be the single biggest wall that all quantum developers are running into. The conversation is rapidly shifting from can we build one good qubit to can we build millions of them.
So, from a strategic perspective, what does ALP deliver? Well, first, it's a universal reliability layer that works across different platforms. It turns your theoretical goals into things you can actually manufacture. It provides that critical bridge from a single prototype to a scalable processor. And maybe most importantly, it frees up your most brilliant, expensive engineers to focus on quantum architecture, not on fighting the fundamental physics of a noisy substrate.
You know, for years, this has all been about a numbers game, a race for the most qubits. But this quote signals a massive shift in the landscape. The winners in the quantum race won't be the ones with the most qubits, they'll be the ones with the cleanest qubits. Quality, not quantity, is what will define the next chapter of quantum computing. Ultimately, the future of quantum computing depends on this one simple but profound shift, from making things small to making them clean. And the only way to truly win that new race is to solve the problem where it begins, at the atomic level. Thanks for your time.